Hello and welcome to this fourth algorithm selection and development lecture in this course, Mastering Artificial Intelligence. So in this section, we will continue, in this lecture, we will talk about, we talked about Shillard score as one of the ways to measure the performance of the cluster algorithms, right? So we will look at how does Shillard score measure how similar an object is to its own cluster compared to other clusters as a part of this whole section focused on research, select and develop appropriate algorithms. So this, as we saw, to link it back, we are at the stage of how to determine the outputs and evaluation matrices, and we have covered classification and regression, and we are now talking about the clustering and the evaluation matrices. So we are looking at the evaluation matrices, and the first one we are looking at is the Shillard score. So how does Shillard score measure how similar object is to its own cluster compared to other clusters? Any thoughts? Are you aware of this? So it's a matrix. First, it's a measurement that is used to evaluate the quality of clusters in a clustering algorithm. So once you do the clustering in a cluster by through a clustering algorithm, you can use this to measure the quality of clusters. How good are the clusters formed by the algorithm? And it measures how similar an object is to an own cluster compared to other clusters, because that's the whole purpose of clustering. The objects in a cluster should be closely related to each other, right? And this is what it does. Now, how does it do that? Let's take a look at that. So first, what it does, as you see on your screen, there are three clusters, A, B, and another one. So for each data point I in the data set. So let's look at the cluster in which the A resides. So first you calculate the average distance between the I point and other data points in the same cluster. So you take one point I and other data points in this cluster, and you take an average distance between them, and this is denoted as AI. Similarly, you calculate the average distance between the same data point I and all data points in the nearest neighboring cluster. That's the represented here by the pink cluster. So white cluster, pink cluster. The cluster with the smallest average distance, nearest neighboring cluster. This is denoted as BI. Now, the Shillard score SI for the data point I is then defined as SI equal to BI minus AI, as you see, divided by max of AI BI. So that's how the Shillard score for I point is determined in the white cluster. And for the entire data set, the Shillard score is the average of the Shillard scores of all the data points. So if there are one in the 5 data points, for each one you do this. And if there are 10, if there are 100, you do this and you calculate average. And since it's a computer and program, it's easy to measure this. Now, the question is, next question, after having measured Shillard score, the next question is, how do you interpret this score? So the Shillard score ranges from 1 to +1, and it basically high Shillard score, indicates that the object is well matched to its own cluster. If the score is close to 1, then your object is well matched to its own cluster, and poorly matched to neighboring clusters, indicating that the object is in the right cluster. This is in the right place. Now, if on the other side, if the Shillard score is not other side, but if it is in the middle, it's close to 0, that it indicates the object is on or very close to the decision boundary between the two neighboring clusters. So it's kind of halfway house. And if you have a negative Shillard score, that indicates that object may have been assigned to the wrong cluster. That means your object is the wrong cluster, as it is more similar to neighboring cluster than its own cluster. And that raises the question on whether the clustering has been done rightly. So a +1 score indicates confirms right clustering, -1 indicates wrong clustering, and 0 is a question mark. So that's how you interpret the Shillard score. So the next question is, how do you use the Shillard score for cluster evaluation? Now, this overall quality of cluster can be assessed by examining the distribution of silhouettes across all data points. A high average silhouette score indicates that the clusters are dense and well separated with clear boundaries between them. So it's a good clustering that has been done by the algorithm. On the converse side, if the low silhouette score with a low average silhouette score suggests that the clusters are overlapping and poorly defined. Now, silhouette score it does provide a way to quantitatively evaluate different clustering algorithms, parameter settings, and number of clusters that have been formed by the algorithm. So in summary, silhouette score measures the compactness or separation of clusters in a done by a clustering algorithm by comparing the average distance of each data point to its own cluster with the average distance to nearest neighboring cluster. Higher silhouette scores indicate better cluster quality, while a lower score suggests that the clustering may be suboptimal. So what is next? So we will look at the second cluster evaluation matrix, Davies-Bouldin index, and we will look at how does the Davies-Bouldin index compute the average similarity between each cluster and its most similar cluster. So thank you so much for watching this fourth algorithm selection and development lecture in this course, Master in Artificial Intelligence. I hope you're continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer a question. And also download the PDF file to take a look at anything that I have shown you in detail.